Okay, so let's look at the revision for question 4. It was really not a difficult question except for the question 4.2, but we'll look at that. First, they were given that f of x is equal to a to the power of x, and then they ask us to determine a if f goes through the point, and then they give us a point that's on the graph. Did you get that one right?
I don't think so.
Oh, well, tell me, what would you do? You have to find that value a. How would you do it? You don't look there. Now, based on what we've talked about.
I would substitute the points given.
Okay, so we've got y is equal to a to the power of x. So they give us a point. Y is 2, x is half, so a to the power of a half, and then?
And then in order to work out a, I would use the log method.
Log won't help because you use log if you're trying to solve the exponent. We don't know.
I would, you call it?
Square root?
Yes, by
okay.
now.
So would you put it as this? Is that what you mean?
No, I mean...
That's what you should mean. Yeah.
But half is square root.
Yes.
Because, okay, I'm sorry, it's square root.
No, so what you want is you want to solve a, isn't it?
Yes.
So, but a has a half exponent. How would you get rid of a half exponent? Well, you'll square it. Yeah, so you'll say a half squared, and then we just do that on both sides, and so this becomes a is equal to 4. So here's our function. F of x is is 4 to the power of x. That's our original function. Now they ask us to determine the function, the inverse function. Okay, so the inverse is just flipping the x and y around and then solving y. So y is equal to, I'm going to keep it a for in case someone got the a wrong. Okay, if you got your a wrong, you can still get all of the other questions correct. Okay, all you do is flip x and y around, and now you need to solve for y. Now we can do what you said. How would you use logs now?
Log base. So log base exponent, which will equal to log 4.
Okay, which in our case now a, yes.
Yes, and then in the bracket we'll have x.
Okay.
Which is equal.
Which is our answer. So it's log base answer equal to exponent. Okay. Great. Determine, okay, for which values of x is this greater or equal to 0? So our inverse must be greater or equal to 0. So log of a x must be greater or equal to 0. Now how will I solve this?
I have no idea.
Make it easier. So if you don't know how to work with logarithms, you can work with what?
The normal thing. So I would
say
go
back, yeah.
4 to the power of x is equal to 0.
Equal to the power of what?
A to the power of x.
X? No.
0.
A to the power of 0
is equal or bigger than x.
Is bigger than x. So now we want to know which side must go which, and it would go in the direction of h. So x will be greater or equal to.
Why does it go to the direction of x?
Well, the point is, I think the best way I can explain it is by showing you how can we get rid of a log in an expression like this. So if I had it, and it's going to seem a little bit weird, but if I have an expression like this, if I do on both sides, I make this the exponent on both sides. So I take my base, which in our case is 4, and I give it, and I make this the exponent, log ax is greater or equal to a to the power of 0. You see, I took both of the, I took this value and that value and just gave them as the exponents on both. So if this side is greater than 0, then the base of that side is greater or equal to the base on that side. Does that make sense? Now, there's a law that we don't really look at called, I can't remember what it's called, but basically what it says is when you have a base and in the exponent you have log of that base, then it just simplifies to whatever is inside there. Okay, there's another one that says if we have log, and inside the log, a log of a base, and inside the log of the base we have the base with an exponent, it also simplifies just to the exponent. Now this one is easy to show because we can just say, well, that's x, this is log b is equal to 1. This one's proof is also not difficult, because if I have base exponent equal to answer, if I write this thing as logarithm, then log of, then my exponent is, that's my exponent, that's log bx is equal to, my exponent is equal to log of my base with my answer, in this case x. You see? So we can see that actually we want to know what this is equal to. If I want to simplify this, what would it be equal to? And then I see, well, whatever it's equal to, these two equations are the same. The left and the right is the same except for the inside, which means that this question mark, what does this simplify to? It simplifies to the question mark, but if I rewrite it, the question mark is in the place of the x, which means that question mark must be x. Does that make sense? Okay, so in other words, if I do that now, that means that this thing can simplify to x is greater or equal to 1. Okay, the easier way to have answered this question, for which values of x is the inverse greater or equal to 0, is just to draw this function, is to draw that and then look at the graph. So let's quickly draw that. You remember what it must look like now? Log of 4 with the base 4.
It's going to go, I'm thinking like that.
It's going to go, so let me ask you this, is it going to be, is it going to go from the bottom up or from the left to the right? Let's first decide that. So am I going to cut the x-axis or am I going to cut the y-axis?
The x-axis.
Okay, so I'm going to cut the x-axis. So I'm either going to cut it like this or I'm going to cut it like that. Am I going to closer to the negative y or to the positive y?
Closer to the positive y.
So are we going to look like this?
Yes, I think so.
You think so? Okay, so again, notice now what this is saying. This is saying when x goes to infinity, y goes to negative infinity. So look here, when your x goes to infinity, your y will become negative. The reason why that's impossible is because you are saying, for what exponent must I give you to get a big number? And you're saying a negative exponent.
No, that's not correct.
That's not correct, right? So it would be maybe helpful to let's draw the original one. What will the original one look like? That one.
It would go from getting closer to 0 to the positive.
So you're saying this direction?
No, the other.
This direction?
Yes.
Okay.
And that's why the last time I said.
Okay.
Because I realized that's the inverse.
It is the inverse. So let's quickly see how, if this is the original, what will the inverse look like? So the original is close to the negative x-axis and further away at the positive x-axis.
Yes. So that means that our y has to be closer to the y-axis and then further away from the y-axis.
Yes, but at which side? At the negative side or the positive side?
At the...
Here, this one is close at the negative side, so this one must be close at the
positive side.
No, also the negative side. Just the x and the y values change.
Okay.
So it's close at the negative with negative x values, so this one must be close with negative y values. It is far with positive x values, so this one must be far with positive y values. That's all that changes. Everything doesn't swap around, it's just the x and the y values. Okay, make sense?
Yes.
So this one will look like that, and in the end it has to be a reflection in the line y is equal to x. Ugh. Okay. It has to reflect in the line y is equal to, and this is almost a reflection. Okay, except for my crappy drawing. Okay. So this is the graph. Okay, now what is the intercept here? What type of intercept is it?
X to 0.
Okay, so it's the x-intercept.
Yes.
So what must we make 0?
Y.
Y. So if we say 0 is equal to log of 4 to x, what is the x value?
We're looking for x.
Yes, we want to solve x. How will you solve x in this equation? Whenever you struggle with logs, go back into exponential. So how can you write this expression in exponential form?
4 to the power of x.
That's not 4 to the power of x.
4 to the power of 0.
4 to the, so x is equal, the inside is equal to the base and the answer. Okay, so 4 to the power of 0, so x is equal to?
1. Oh.
How easy is that? Huh? Okay, so this x value is?
1, 0.
1 for x, 0 for y. Okay, so let's go back. So this is our graph.
Yes.
For which values is the graph greater than 0? So we're looking for the graph greater than 0. Do you see here's the graph? And the f, these are y values. For which values is the y value of the, we're trying to find the x values so that the y values is greater than 0. And these are all the y values greater than 0. Do you see? Now what x values are associated? These x values. All the x values from 1 upwards will cause the graph to be bigger.
And that's why you say
x is greater or equal to 1. Okay, another way to just look at it is that if I have y is equal to log of 4 to the power of x, if I'm asking you, when will the y values be greater than 0? That is saying, what exponents must, what answers do I get when my exponents are greater than 0? So in other words, 4 to the power of y is equal to x. If they tell me my y values, that's what they mean here, y values is bigger than 0. If my y values is bigger than 0 the whole time, then 4 to the power of those values will always be bigger than 1. Because the moment y is 0, my answer is 1. If it's more than 0, then it must be more than 1. Make sense? Okay. Okay, there's many different ways of looking at that. I think the graph is the easiest way to understand it. Determine the function of h if the graph of h is the reflection of f through the y-axis. Now if I reflect in the y-axis, notice what used to be here now goes there.
yes.
So what used to be a positive x value now becomes a negative x value. What used to be a negative x value now becomes a positive x value. So if f of x is equal to 4 to the power of x, h of x is the reflection in the y-axis. What do we do then? What should get a negative? A reflection will always cause something to become negative.
Yes.
Well, not always, but a reflection in x and y. One of them will get a negative. Which one?
I think we're gonna say the function of hx is gonna be minus 4 to the power of x.
Okay, now look what happens if you put a minus in front here. That will take every f value, every y value, and change the sign. You see that? So if you have any y value, it will change the sign that way.
Okay, so that means I'm wrong.
Yes. Whenever we reflect in the y-axis, my x gets a negative.
Okay.
You can just even remember that, but it does make sense because whose sign gets changed?
The x.
The x's sign gets changed.
Okay.
So this becomes 4 to the power of negative x. Make sense?
Yes.
Determine the function k if k is the reflection of f through the x-axis. Now I'm reflecting in the x-axis.
Yes, so now it would be negative 4 to the power of x.
Exactly. Now we just take our y value, f of x, and we multiply it with a negative. So this is negative 4 to the power of x. Well done. Okay, determine the graph of p if p is obtained by shifting the graph of f 2 units left. So I've got f of x, or p takes the graph of f and shifting it 2 units to the left. Now here, I'm not going to go into the detail now, I should, but my time is almost up. Okay, whenever I shift to the left or to the right, I'm changing x values because I'm going horizontal.
Yeah, you're either going to add or subtract.
Exactly.
And since we're going left, I'm thinking 4 to the power of x minus 2.
Okay, so most people make that mistake. When we go left, we subtract. But let me quickly show you why that is not true, okay? So I do want to go into that. Most people make that mistake. Here is a vending machine. Okay, here's our Cokes. And a Coke is going to be 10 Rand in this vending machine.
Okay.
Whenever you give me money to go get you a Coke, I take 2 Rand. So how much money must you give me?
12 Rand.
12 Rand. So if you subtract, which way is the input going? So I am subtracting from what you are giving me.
So,
And yet now, if you want the same result, do you need to go left or right?
if I want the same results, I need to add.
Yeah, so in other words, you want a 10 to go in here. The input must still be 10.
So that means.
But before it gets, so in other words, 4 to the power of x. Okay. But before it goes in, I take 2 Rand.
That means that it won't be enough for the Coke.
It won't be enough. So to get enough, what will you have to give me?
I have to add.
You have to add. So the graph has to shift to counter the -2.
Okay.
Do you understand? So a 4 to the power x minus 2 is a graph that must shift to the right to counter for the -2. Because, let me give you an example. The original graph looks like this. When x is equal to 1, y is equal to? The original, 4 to the power of x.
When x is equals to 1, y is equals to 4.
4, I just put a 1 in there. Okay.
Yes.
Now, the graph 4 to the power of x minus 2. If x is now equal, so now let's say you want to get 4 again, 1 again. You want the result to equal 1. What must you give x now? 2. If you put a 2 in there.
No, it's gonna give.
Oh, sorry, this must be 4. 4, sorry, that's my mistake. Let's say you want to have 4 again. So when x was equal to 1, in the original graph, if I put a 1 in, I get a 4.
Yes.
Now I want 4, but each time you give me something, I take 2. Do you see? My x is being manipulated here. So what must you put in now for x to get 4?
3.
3. So now I can only get 4 when my x is 3. So the point that used to be there is now there.
Okay.
I used to, if x was equal to 0, I used to have 1 here. Now, if I want this to equal 1, I must have a 2 there. 2 minus 2 now gives me 0. So I will now, this point will move to there. So here, this is what my graph starts looking like. So even though I've subtracted 2 from my x, my graph shifted to the right. Because I need to compensate for the stealing of my inputs. Do you see? Now it's not the same when my graph shifts up and down. Because if this is 4 to the power of x plus 1, I still get my output and then I add 1. So my graph just shifts up.
Yes.
It is when the input, so for example, each time you give me 10 Rand, if I put it in, okay, I get a Coke out. Now, after I get the Coke out, I take a Coke for myself. You don't need to compensate anything for the output.
Okay.
You only need to compensate when there's an input. Okay, so this graph will shift up. Okay, so if my graph is shifting, if they tell me that my graph has shifted, my graph has shifted to the left.
That means we need to add.
I'm adding, yes, because now if I keep adding 2 rand, you don't need to give me 10 rand, you only need to give me 8 rand. So things happen sooner than they used to happen. So if my graph is shifting to the left, things is happening sooner, which means things are being added to my x without me adding it. Okay, great. So this function, this will then be 4 to the power of
x plus 2.
Plus 2. Excellent. Let's now quickly go and just write them here. This one was 4 to the this one was log 4x. This one was 4 to the power of negative x and negative 4x. Now they ask me for the domain and the range of each. Now we've looked at domain and range, a lovely 10 marks there. Okay, which is just amazing. Okay, so let's quickly see my original function there. Domain is again what? How would you describe domain to someone?
Domain is the x values, the possible x values for your function.
The values I'm allowed to put in. So possible is not the right word. It's allowable. There's a difference between possible and allowable. I am able to kill you, I'm sure. Depends on how strong you are. But I'm not allowed to. Do you understand what's the difference?
Okay.
Well, with your range is the
output.
Is it allowable outputs or possible outputs?
Possible outputs.
Possible outputs, exactly. So x is, the domain is what I'm allowed to put in according to my rules. There's only 2 things I'm not allowed to do, well, 3 things. I'm not allowed to have negative in the root,
Yes.
0 in a denominator, or 0 or negative in a log. Those are my 3 rules. I'm not allowed to break them. Range is what am I able to get out. I'm just simply not able to get a fraction to equal 0. It's impossible, no matter what I do.
Yes.
Do you understand? It's impossible. So that's helpful. Okay, let's quickly see. F of x, what is this one's domain? What am I allowed to give as an exponent?
For the original function.
Yes.
Real numbers.
Real. Yeah?
From 0 upwards, it still give you.
Yes, it's not one of those rules.
Yeah.
There's only 3 limiting factors. Roots, what was it? Roots, denominators, and logs. Okay, so now we know that the inverse is going to be a problem, isn't it? There's our inverse. What is the limit? What is allowed for x there?
X can be any number except for 0, because with log you can't have 0 where x is.
Think of the log graph. You're right, I never touch the 0. X can never be 0.
Yes.
But what else can it not be?
A negative number.
A negative number. It can never touch 0 or pass 0. The only graph that only has a single value unallowed is the hyperbola.
Okay.
This one will have, the condition will be x must be greater than 0. Or whatever is in here, whatever is inside the log must be greater than 0. Okay, hx, that one?
Hx cannot. Okay, because we have a negative exponent. Negative exponent means divide. And when you divide, the sign doesn't change. It stays the same. So it can never have a negative base.
But my base is 4. My base is fixed.
Yes, doesn't
So
change.
4 is 4. The answer, again, the question is, if I'm talking about my domain, what am I allowed to put in as an exponent?
Any number.
Any number. There's only 3 things that I'm not allowed to do. Now, you're right. A negative does mean divide. So I actually do have a denominator. But this denominator is a what? What do I call that expression? 4 to the power of x is an exponential expression.
Yes.
Now, my denominator may not be 0. It doesn't mean x cannot be 0. My denominator, and my denominator is already an exponential function. Exponential functions can't be 0, no matter what I put in for x. Okay, so in an exponential function, always, so even that one, kx, x is an element of r. This one, x is an element of r. Okay, any exponential expression, I can take any real one. So there's really actually 5 free marks. These were the easiest marks in the paper. I'm sorry to say, no, really.
That's not fair.
Just because you didn't get them doesn't mean they are difficult. Are they difficult?
No, they're not.
They're not difficult. You just didn't know.
Yes.
Okay. Doesn't make it difficult if you don't know. Okay. The range is maybe a little bit more difficult. Okay. What is the range for the... So a range is what can I get out? What can an exponential expression... And again, look at the graph. Here's the original one. What can it be?
Well, it can be all the real numbers because except for 0 because then it starts close to 0 and shifts away from it. So I would say any number above 0.
Perfect. So do you see how helpful it is to know the graphs?
Yes.
Know your graphs. So y can be any number greater than 0. Okay, for this one, what can this one's range be? It's what y values?
I'm thinking any number. Wait, when reading the graph, we read from right to left, right? Or left to right?
No, our question is what y values can we get?
The range.
In other words, so choose any y value and then you go horizontal and see, do I cut my graph? Yes, I do. Yes, I do. Yes, I do. Yes, I do. Yes, I do.
So it's basically any number.
Any number. Because this graph goes from down here, from negative y values, the smallest I can imagine, to as high. Now, it doesn't grow so quick to the top, but it does go to infinity. Eventually, in heaven, you'll see. If you're going,
Well, I thought it's going to have an asymptote somewhere there.
No, there's not an asymptote there. There's no asymptote there. Okay, so this one, y is an element of real numbers. Now look here quickly. This is the function, and that's its inverse. Notice they just swapped around. What used to be my domain now becomes my range. That is a very important thing to know. My domain becomes my range. Okay, h of x, that's this one. Okay, so remember what this one said. This one is the graph is reflected in the y-axis, which means it's this graph reflected in the y-axis. So this one now looks like that. Did the range change?
No.
It's the same range.
Yes.
You see, if it reflected in the x-axis, yes, then it would change. So this one's range must be the same as the original, isn't it?
Yes.
Okay, how about kx? This one's range.
K minus, okay, the range, because, y is equal to 4x. What are the possible y values that we can get is we can never get a negative y. No, we can, because if you say to the
no, you're on the right track. This one can never be negative.
yes.
But now I put a negative in front of it, so what can it never be? So this is negative 1 times something that is always positive.
So it can never be positive.
Exactly. Because I will have a positive thing that's always positive and that's multiplied by a negative, so it doesn't have a chance to change it back into positive again.
But okay, so let's say we substitute x with 3.
3.
Yes.
So then we get 4 to the power of 3, which is 64. But there's a negative here. So remember, that negative, okay, so that's negative 64. That negative is not multiplied with itself 3 times. It's not part of the base.
It's part of the coefficient.
It's the coefficient. If it was like that, yes.
Okay.
But it's not. Now let's just go look at the graph. Reflecting in the y-axis reflects this way. Reflecting in the x-axis reflects that way. And now the same method you used to understand that it can never touch the 0, it's true, but now it's always on the negative side.
Yes, so then it's smaller than 0.
Yes. So y is always smaller than 0. That's how I would write something that can never be positive. Y is smaller than 0. The last one, this one.
Y is, okay, since now by our exponent we're adding something. X. I don't think x has limitations.
Okay, here was the x value, the domain. We've already considered it. You were right. X doesn't have any limitations. That it's not
so
allowed.
If x doesn't have any limitations, that means that y.
No, these x doesn't have limitations either, but their y's were different.
Yes, but with this one, I think that y is the element of real numbers. The reason I say that is because no, but you can never get a negative y.
That's it. So it must be positive.
This is tricky.
It is tricky, but you could figure it out. You see, it really comes down to that. There's only two things that's impossible. It's impossible for a fraction to equal 0. Okay, and it's impossible for an exponent, a base exponent, to be, this will always be greater than 0. So this will always be unequal to 0, and this will always be greater than 0. And then there's another thing, x squared will always be greater than 0, or equal. So these are the same 3 rules that we did before. Okay, these are just impossibilities. Where that fraction can never be 0 and x can never be 0. The exponent can never be 0 and log base x, where x must be greater than 0. You see there's a relationship between these rules. And this is where x squared must be greater than 0, and the same way the square root of x, then x must be greater than 0 or equal to 0. You see that? Okay, excellent. Oh, okay, those are the limiting factors. Great. Let's just quickly look at the second part of this question. This was a fun question to set. Okay, so what does this mean? Find the x values for which this is true. What does that mean?
That means that the function of the fx is equals to gx.
What does fx mean? What does it represent? X values or y values?
Y.
Y values. So we want the y value for f to equal to the y value for g.
Okay.
Does that make sense? Now what x value will have these two to have the same y value? Okay. Okay, don't look at your. Okay, for what x value will both of them have the same y values?
-1.
-1, because then both of them will have a y value of 1. So here x is just equal to -1. Now here, interpret this the same. What does this mean?
The y of gx minus the y of fx is equals to 2.
Yep.
So from the graph I can say the y of 2, no, let's say 3 from gx, and then minus.
Are you using this 3?
Is minus.
Okay, no, but look here. If you're using this 3, then x is 1.
And then we're supposed to get 2.
Yes, but now this one is -1/2. Do you see? So we have to have the same x value. So if you use 3, then you're using this distance between these two. Remember, if I subtract, I'm working out distance.
Okay. So the distance has to be 2 between the y of gx and the y of fx.
That's true.
How about 0 and -2? No, but I'm looking at the y, the x values.
Yeah, don't look at the x values. Yeah, so you're right. Here, the distance is, but that would be, then you would be finding the y value. If y is 0, then the difference between the x's is 2.
How about the +2 from gx and the 0 from fx?
So what is the 0, the x value for which this will be true? So look at this. If x is equal to what?
Oh, 0.
If x is equal to 0, then g of 0 is 2, and f of 0 is 0, then g of 0 minus f of 0 is equal to 2.
Okay.
You get it? Okay, now that's a fun one. This one is a tough. I like this one.
That looks complicated.
It does look complicated. It is actually slightly complicated.
So what that means is that the what do you call that? The first.
That's not the derivative.
I mean the inverse.
The inverse
of fx times.
That's not times. This. Let me interpret this for you. What value must I give for x, so that if I put that x value into g, I'm going to get an answer? So let's take 2 for example. I'm going to get an answer 4. Okay. Now if I put 4 into the inverse, I must get -2. Do you understand? So my question is, what value must I find so that when I put, so I'm saying I want to put a value into the inverse and get -2.
You have to put in, to get -2 0.
So let's forget about gx now. Let's just say this was the question. Let's say that was the question. So forget about what's inside there. What would we like to put inside here to get -2? Sorry, that must be a -1.
What must the y value be so that it could equal to -2? Is that what you're asking?
Of the inverse.
Yes.
So remember, the inverse gives me -2. But what is the inverse? How do I get the inverse?
You do the first derivative.
So
You change y and x.
you change y and x. So this is saying this is equal to negative 2. Is this the x value or the y value?
Oh wait, if that in our original equation is y, that means now it's x. So x. So if the answer is negative 2, wait, I know the answer now. Okay. Then we have to put in negative 3, I think.
In here?
Yes.
In my inverse. Okay, so you are saying so you are saying that the point negative 3 comma 2, this is a point on the inverse.
I think so.
Okay, so that means that 2 comma negative 3 is a point on the original f. Let's see. 2. No.
No, it's not.
So you want the point. No, sorry, I'm wrong. You're saying we should. Did you say we should put in a negative 3? Sorry, this must be negative 2. Let's just try that. Negative 2 and 3 and positive 3.
Yes.
Is that what you said? A positive 3? I can't remember what you said.
I just said 3.
Yes, so then you were correct. So sorry, I messed it up. Let me start again. You said if we put a 3 in there, we'll get negative 2. So you are saying on the inverse, if x is 3, y would be negative 2. Which means that if I turn this around, this must be a point on the original function. And it is. Do you see? When x is negative 2, y is 3. So you are correct in that you are saying that f of negative x, f of 3 would equal negative 2. Okay? So we want g of x to equal 3.
Okay. Let me try that. G of x to equal negative 2.
No, g of x to equal 3. Because look here, you said what we should put in here is a 3. But what's currently in there is g of x.
Yes. So we need g of x to equal to 3.
Yes.
From the original graph, not
From the graphs now, yeah, this is just g of x.
No. That means that we have to put in 1.
Exactly. No one of my students got this correct. Even though you only had 1, 2, 3, 4, 5, 6 guesses, no one even guessed it correct.
So this is complicated.
It is. That is one of the most difficult questions in the paper.
Yes.
Now, don't expect yourself to get everything correct, but you can see it makes sense. It is complicated. There are complicated questions in the paper. Some are very simple, like the other ones. They were very simple. All you needed to do was study domain and range, and you could have gotten that one. This is very complicated. Let me show you another way of doing this. The inverse negative 2. One way that the inverse can be used is if your inverse is here, to get rid of an inverse, you can, for example, the inverse is defined as that value that when I put it into my original function, I'll get x.
Oh.
This is the definition. If I put the answer of my inverse into my original function, I'll get my first function. Okay, that's it. So in other words, if I take f of this on both sides, I can get rid of, so do you see, it's almost like they're cancelling one another out.
Okay.
So now I just have g of x is equal to f of negative 2. F of negative 2 is 3. So when is g of x equal to 3? When x is equal to 1. You see, so that, but that's this is something you only learn in, this is something you only really use in university, when we actually use the definition of a function. And so it is a complicated question, but you could have figured it out by just understanding. Another way you could have understood it, or the way that I thought about it when I thought the question, was to think of, okay, so the inverse, I'm swapping x and y around. So the inverse is now using this as my x values.
Yes.
And I want to get a y value of -2. So I have to use, to get, this is now my y value -2, so I must use my x value as 3. And now I know, so gx must equal 3. And now for gx, that's a y value now, because I'm not working with my inverse. That's a y value must be 3, so x must be 1. So it is complicated, but there must be questions. These two weren't. This was a knowledge question. We get 3 level 1, level 2, level 3, and level 4 questions. This was a level 4 question, this was a level 2 question, and this was a level 1 question. Okay. Now level 1 questions make up 20% of your exam, level 2 question make up 35% of your exam, level 3 make up 30% of your exam, and level 4 makes up 10% of your exam. 15, sorry. In my papers, in my tests that I set, level 1 is 15, level 2 is 30, level 3 is 35, and level 4 is 40. Sorry, not 40, 20. So I weight them higher here in the top, so that when you get to the actual exam, your exam will be easier than what you've been experiencing in the year. Okay. So the mark you have there, you can expect to get a little bit more than that. If you know the easy questions, because now the easy questions you didn't get. Okay, so that's not helpful. So you have to know your theory. You really, look, if you just do your theory, that's the first two. Level 1 questions are knowledge questions. That's like knowing what is domain, and I can just look at a graph. Like, I know any base to the exponent, that is the range, and I know y is equal to, sorry, that's the domain, and that without the equal, that is the range. Y is greater than 0 is the range. These things you must know, and that's level 1 questions. Level 2 questions are questions that you've seen in your class, you've done it, it's normal questions. It's typically like what question can I imagine now? Like just a basic question, the routine, it's called routine procedures, is the routine questions. Level 3 is complex questions. That's a combination of different ones to find a solution. Like, for example, you have to find out the how long will it take before your investment. So you do monthly installments. You have monthly installments, so you use this formula, and now we want to ask, how long does it take? How many installments must you make before you have 100,000 there? Now, that combines two things. It combines annuities, and then you must solve n. You must try and solve n in this equation. So that uses logs as well. So it's combining two themes in maths. That would be level 3 questions. So, and they can be complicated. They can be questions that you've never maybe seen before as well. Level 3 can also be just, it asks you a question, you've never looked at it like that. Or, for example, when there's a lot of different changes in the interest rate. Those are complex questions. Okay. Level 4 questions are problem-solving questions. They are questions that you probably need to change, like in this question. You needed to interpret this in a different way. It wasn't something you had the knowledge to do. You do, but only once you've changed it a little bit into a way that you can work with it. That's problem-solving questions. So, but you can see from knowledge questions what you need to study, what you need to study and what is routine, what you must be able to do and get 100% for, makes up 55% of your test. You can get at least 55, even if you get 0 for the rest, and it's very unlikely to get 0 for those. Okay, so I expect nothing less than 60%. All right.